Here is my Lego Technic mechanical calculator. Here is a summary of all the controls we have. First we have a basic on-off switch that turns the battery on and off. Then we have this switch here connected to a switch there that runs the motor in two different directions for running the calculator or resetting it. Then we have these two long rows of buttons. This one over here is going to be for the input, or the first number that we input. This is for the second one. At present, the calculator only works with two single-digit numbers, but that may be able to change in future versions. Up here, you see we have this dial. It should be reading 0 there. That's indicating what number has been input on this side. This side is also at 0 for this side. And then finally, this switch here switches between adding and subtracting. Also, this dial here is the final output dial. Right now it's reading 1. It should be reading 0 like that there. First, I'll try to explain how the calculator works, and then after that I'll demonstrate it working. So if we look down here, the heart of the device is these two long axles with these things sticking out. There's 9 of them at all different angles. Ideally, there should be 10 positions for each of the digits. I only have 9 because 0 is, in my design, a sort of a default space in between two. Ideally, they would be 36 degrees apart exactly, but Lego doesn't allow for that, so it's actually only an approximation, with some gaps being a little more than others. But it still works reasonably well. So this power functions medium motor up here runs this clutch gear, which runs this 28-tooth gear, which runs these. So the motor, when it's in operation, is always running, but the dials are not moving because they're not engaged. So if we reset the motor, we run it in reverse, nothing's happening. So let's say it actually was at some number, random numbers. So then in order to reverse it, I press the 9 button, which engages engages the driving ring, causing this to rotate back to that cheese slope there, zeroing out the dial. And the same works on the other side. So I press this, engages the driving ring, and reset that half beam in the center to the 0 position. So the 9 button I was pressing looks like this here. It presses this long linkage, which engages this driving ring here, just barely because I don't want it to engage too early or too late. Now the 9 button is unique in that it moves this 3-long axle rather than a 4-long, so it actually never stops the dial from rotating. It allows it to rotate until it hits the physical stop there. With any of the other buttons, this isn't the case, though. They all similarly engage the driving ring, but they do not let it go to its final stopping points. They stop it themselves, so if I turn it back on to run, first I'll press the 1 button, causing it to rotate until it hits that axle. 2 button, lets it go a step further. 3, 4, 5, 6, 7, 8, and then the 9 lets it go until it hits the other side of that cheese slope. So because the largest number I pressed in that sequence was 9, that's the value it has gone with. So our output, or our input reading dial says that I have pressed 9. So I'm going to reset it now, which is always done by pressing 9, the dial goes back to 0. I'm going to set it back to run, then I'm going to press the button sequentially and watch it go up through the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, So as you can see, these two sides with their respective dials, they function pretty much the same way, with the final result that the larger the button you press, the more the dial and axle rotates, and the more degrees there are of rotation. So then, basically, each side of this runs into this differential here. There's a bit more to that I'll get to later, but it comes in both sides to add up the amount of degrees. So if this one has rotated, say, x degrees, let x degrees be the amount it does for one number. If this one's rotated 3x degrees, the output of the differential, after it's geared up 2 times to that 12-tooth gear, is going to be, I forget what my digits were, I think 4x degrees, or it's going to add it, just the mechanical way that differentials work. In practice, though, my mechanism is slightly more complicated. Rather than having my two halves go directly into opposite halves of the differential, I include a reversing gearbox on this second assembly here. So it's controlled by this dial to switch to negative, positive, and the center locks it. So if it's on the positive side, this side rotates in a direction so as to assist the original side, so that the sum of their two angular displacements, the amount they have both rotated, will be greater, and we'll get a large number. That's how adding works. But if I flip it the other way, this one will now be fighting this one. So if this one turned 5x degrees, and this one only turned 2x degrees, it's going to be going the other direction, making the sum only 3x. So the actual gearbox, you can see down here, the input would be right here on that axle. The output is this one here. So as you can see right now, we have that driving that, which drives the tan gear there, which drives these gears. So right now, the input and output go the same direction. If I slide it into the middle, it locks, which hopefully will keep the numbers from getting misaligned in between shifts. And then if I move it to the other side, it now drives directly from up here without going down there first. So now they're going opposite directions between input and output. Actually, I think I had it backwards before. Before it was opposite, now it's the same. This gearbox design was chosen over a more simple transmission driving ring based one because of the key characteristic of low backlash, because backlash is the enemy of accuracy in this system. If I could get rid of any more, I would do it, because it works somewhat imperfectly as it is, but I don't see how it can be done. So anyways, after this gearbox and this go into the two sides of this differential, it drives this 12-tooth gear, multiplying speed times 2, and then, in order to make my dial go through one full rotation, I had to reduce the speed 3 times, with this 12 to 36 ratio. So you can see my dial here. I've got all the integers from -9 all the way up to +18. As I mentioned before, my calculator only allows single-digit numbers, so the smallest number I can get is 0, -9, or -9, and the largest number I can get is 9 plus 9, or 18. Perhaps in the future I'll be able to come up with a more sophisticated design, but for now that's all this can do, and that's also all the dial needs to output. So let's try a practical test of this calculator. I'll set the motor to run, then on the input side let's try number 6. So my dial here has gone to 6. Similarly, the dial up here has gone to 6. You can see there. Okay, 6 equals 6. Anyways, we're in adding mode. Now I'm going to add, let's say 4. So I'll press 4. We have a 4 here, so we have 6. And it looks like it got a little dislodged. 6 plus 4 equals, you can see there we have a 10. Let's try some basic subtraction. I'm going to set this to run. I'm going to hit 9 over here. See, we got a 9 there, and I'm going to try hitting a 6 over here. Got a 6 there, You subtract those numbers, you get 3, which is a little hidden. I've got some slack, so it's not quite perfect, but you can see I definitely do have a 3 there. What if we try some subtraction resulting in a negative number? So we hit run, let's press 2 over here, we get a 2 on that dial. Over here let's hit 7, got a 7 there, and in the dial, if it focuses, you can see we got a -5 right there. And now for a final test, let's try making the biggest number we can, 9 plus 9. Set it to run, hit 9, and 9, and just kind of hit the button a few more times just to get everything coaxed right, and there we go, 18. I will be honest that this thing does not always give you the answer you're hoping for, mostly because of just the necessary backlash in the system. Gives us a degree of slack. At present I don't have any solution to it, but hopefully I can come up with something in the future, and it worked acceptably well for me, especially since this was my first time trying to make something like this. It was a very interesting experience, and I'm glad I did it.